Okay, so in this part of the lecture, we are going to find out how is modular arithmetic applied in other cases or applied in the real world. Like for example, in ISBN or International Standard Book Number, and in UPC, these are the numbers that you find under the barcodes in grocery stores and credit card numbers. So let's start with ISBN. So every book that are being sold contains or has an ISBN number, okay, or is cataloged using an ISBN number, International Standard Book Number. So this usually is how long or how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the digits has some significance. So there are a group of numbers separated by hyphens. So let's try to interpret this one. This is an example. So according to this is the ISBN for the American Heritage Dictionary, third edition. So the second edition would have a unique number. Ano po, even though they are the same book, the same edition but printed by a different publisher will have a different ISBN, unique ISBN to it. So the first number, which is a 0, talks about what language is the book written. So 0 for English. The second set of numbers, which is 395, talks about the publisher or is the code for the specific publisher of the book. In this case, 395 is assigned to this particular publishing house. 44895, that will identify the book, the third edition of this dictionary. If we have a different edition, this will change. And the last digit is the check digit. This is how we will apply modular arithmetic here. So let's go to the next slide. How do we perform modular arithmetic here? So we get the each digit, and we have a multiplier for each of the digits. So starting from 0, since we have 10 numbers, ano po? So you multiply the first number by 10, starting from the left, the second number, which is a 3 by 9, the third to 8, the fourth to 7, and so on. Hanggang makarating dito, this is 5 is the second to the last, so you multiply that by 2. And your check number, which appears here as x, later on natin siya i-input, multiplied by 1. So, hindi na nilagay yung 1 kasi any number multiplied by 1 is still the number. And we are solving in Mod 11 arithmetic. So we are doing the math in such a way that the math should satisfy the congruence. Ano po? So this part of the equation on the left should be congruent to 0 modulo 11. So if you remember correctly, what we need to do here is, if we divide this side on the left by 11, the quotient should be an exact number or a whole number, and the remainder, rather, should be a 0. Okay? Otherwise, if you don't satisfy the congruence, baka merong maling napindot yung ating clerk, for example, the person responsible for uh, the one you find in the counter, the clerk. Maybe there was a problem in the inputting of the number, okay? And when the congruence is not satisfied, so there will be an error in the order, okay? Which would be costly if someone is ordering in bulk, diba? In large number, in multiple copies of a book, for example. So going back to the math here, so 0 times 10 is 0, 3 times 9, 27, 9 times 8, 72, 5 times 7, 35, and so on and so forth. 5 times 2 is 10. So you will just have to add all of this. Maybe you can do this by batch. If you cannot do it all at once in your calculator. So from here to this, you will get a sum of 247. Your x is your check number. Your check number, if you put that here, 247 plus 6, that will be 253. So 253, if I divide it by 11, will I get a whole number? 253 divided 11 is, that's correct, 23. So remainder of 0. So obviously inputting the check number 6, that's why it's called a check number. Adding the check number 6 to the sum 247 will give you a number which when divided by 11 you will have a remainder of 0. Okay, that means you were able to satisfy the congruence, and the clerk was able to put in the correct order. Okay, so that's how the modular arithmetic is useful here. So because ISBN congruence equation, you are solving in mod 11 arithmetic. You have a modulus of 11. The check number, the little x here, will be any number from 0 to 10. Diba? When you are doing mod 11, whole number less than 11. So from 0 to 10. So obviously, you cannot put 10 as your check number kasi dalawang digit na yung 10. So when it is 10, ang makikita mo ay yung big X. One purpose of the ISBN method of coding books is to ensure that orders are placed properly and that books are filed accurately. So for example, tingnan natin what happens if a sales clerk and enter the number incorrectly. So this is our correct code for that book. So 44895, pero dito ang naisulat niya ay 44985. Nakabaliktad yung 8 and 9. So if you do the sum, and then this is your check number, you will be getting this 254. And if you divide it by 11, ano siya? Hindi siya exact number. 254 divide 11, may remainder. Remainder of, so the answer will be 23, remainder of 1. So dapat remainder of 0, diba? So it doesn't satisfy the congruence, and the system know that there's an error in the order. So the clerk has to double check, so he can put in the correct order. Okay, sometimes the problem will look like this. You will be asked to find what is the check number na gagamitin for a certain book so that the congruence will be satisfied. So here, a brief history of type by Stephen Hawking. So these are your codes. You are looking for the check number. So again, multiply each digit starting from the left. 10, 9, 8, 7, 6, 5, 4, 3, 2, respectively. And you will get 155 plus x, which is your check number. What number will you put on x such that it is congruent to 0 modulo 11? So your x can be any number from 0 to 10, less than 11. Ano po? So 155 plus 0, 155. So 155 divide 11, that's not a whole number. 155 plus 1, 156. Check natin. 156 divide 11, 14.18, so also not a whole number. Let's add another 1 plus 2, 157. Still not a whole number. Plus 3, 3 yung ating check number. Let's see. So 158 na tayo. Still not a whole number. Plus 4, 159. Okay, still not a whole number. 160. Okay, you just have to do that until, according to this problem, then 165 pala, indivisible by 11. Okay? So, the correct check digit is 10. Of course, you will not put 10. Big X yung ilalagay mo. Okay, let's do some problems. Let's try it on our own. A purchase order for the book Mathematica, a system for doing mathematics by computer, includes this ISBN. And we have to check if this is valid. Okay. So, dapat mag-valid siya. So, 0 multiplied by 10, 2 multiplied by 9, 0 multiplied by 8, 1 multiplied by 7, another 1 multiplied by 8, 5 multiplied by 7, 5 multiplied by 6, 0 multiplied by 5, 2 multiplied by okay, I made some mistakes. 5, sige, sulat muna natin yung mga digits so hindi tayo nalilito. Okay, so 5, 5, 0 multiplied by something, 2 multiplied by something, and finally the 4 congruent to 0 modulo 11. So ito pala is 7, no, 6, here is 5, 4, 3, 2, and 4 multiplied by 1. But let's not put 1 over there para hindi tayo malito. And we already know that's already the check number. 0 times 10, that's 0. 2 times 9 is 18. 0 times 8 is 0. 1 times 7 is 7. 1 times 6 is 6. 5 times 5 is 25. 5 times 4 is 20. 0 times 3 is 0. 2 times 2 is 4 plus 4 congruent to 0 modulo 11. Let's do this by batch. 18 plus 7 is, what is 18 plus 7? 25. Okay, 6 plus 25 plus 20, 51. And 4 plus 4 is 60. So 25 plus 51 plus 16. Just so we can avoid the errors. 25 plus 51 plus 16 is... I'm getting a 92. 0 modulo 11. 92 divide 11 is not congruent. Okay, let me just check my math. Hold on. Okay, that's why. What am I doing? So 4 plus 4 is a 16. It's not a 16, rather, it's an 8. Ayan, nakakahilo na kasi madaming numbers. 8, and this is not 92, this should only be 88. 88 divide 11, 81 rather. No, 84. 25 plus 51 plus 8, 84. So sorry. 84 plus 11, 84 divide 11 rather, is not a whole number. The quotient is not a whole number. So 11 times 7 is 77. Remainder 7. So this is not a congruence. So what will make it a valid? What will make it a valid ISBN? So for ito ano? So if we, okay, let's break this down. 4 plus x, so 25 plus 51 plus 4, 80. Ibig sabihin, excluding the check number, this is 80. We're looking for a new check number, okay? Don't be confused. So, what will we add with 80, which is less than, what will we add with 80 na less than 11? That will give me a remainder of 0 if divided by 11. I think 1 will be a good answer. Is 1? No, 81 divided 11, that's also 8 rather. 88 divide 11 is 8. So the check number should have been 8, not 4, not 4. Okay? Okay, UPC. It means Universal Product Code. So this is a 12-digit number that you find in the items in grocery stores. And again, meron siyang significance. So the 0, number system character, the second 5, that's the code for the manufacturer. The second batch of 5 numbers is for the item itself. And the last one, like in the ISBN, that's your check number. So, ano yung ginagawa ng mga clerks, the checkout clerk, para mabilis yung pag-process of paying? Ano po, they use a scanner that is able to read the codes, the barcode, ano po. And it is the system that will record the prices. Naka-input na yung prices sa sa system, ano po. And there's an associated price for each of the barcode. Remember, if you have the same product, may iba't ibang ano pa siya, di ba? Variances or variation. Like for example, this product A will be available in 20 grams, in 40 grams, in 60 grams, and so on. So each of those variations would have different prices. So that means they will also have different UPC, different codes. Ano po? So for example, if you have a sale and you want to change the prices of the products kasi may discount, 'di ba? You don't have to manually change the prices doon sa product itself. It can be recorded. You can change up the prices in the computer itself. Ano po? Kasi there's an assignment. There's a unique code for each product. And a unique so you can assign the prices in the PC, not on the actual product, ano po, which will take more time. So what's the mathematics involved here? How do we use the modular arithmetic in the UPC codes or in the UP codes, universal product codes? So if before the multiplier is 10, 9, 8, 7, 6, 5, and so on until 1, here it's alternating 3 and 1, 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 3 and 1 for the check code. And you are working now in modulo 10 arithmetic, mod 10 arithmetic. That means that the left side of the equation, pag dinivide mo sa 10, the remainder should be 0 for the congruence to be true. Okay? So what would make this congruence true? You already have a 104. What would be the check number? So, syempre, 6. Para makabuo ka ng 110, if you divide it by 10, the quotient will be 11, remainder of 0. So 6 would satisfy the congruence. The check number should be 6 for that product. Okay, so dito another problem. What should be the code that should be assigned in this product? What should be the check number, rather, that should be assigned in this product, which has this code? So each of the digit, starting from the leftmost, multiply it by 3 and 1, alternating 3 and 1, 3 and 1, and so on. So you will be able to get a 69. What will you add with 69 Tapos, if you divide it by 10, the remainder will be 0. So, madali lang dito kasi modulo 10 ang you are working with. So, plus 1, that's 70. Divided by 10, remainder of 7, quotient of 7, remainder of 0. So, 1 would satisfy the congruence. That means the check number should be 1. Sige, mag-solve na lang tayo. So, 1, 3, 2, plus 3, plus 4, plus 2. Dapat tama ang kopya mo. 3, 2, 3, 4, 2, plus 6, plus a 5. We are here already. Plus a 9, plus a 3, plus a 3, plus a 9. And then we have to multiply each of the digit by 3 and 1 alternatingly. So this is multiplied by 3, this is 1, this is 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 3. And we are working, we want to satisfy the congruence 0 modulo 10. Okay, let's do the products. 3 times 1 is 3, 3 times 1 is 3 as well, 2 times 3 is 6, 3 times 1 is 3, 4 times 3 is 12, 2 times 1 is 2, 6 times 3 is 18, 5 times 1 is 5, 9 times 3 is 27, that's correct, right? 3 times 1 is 3, 3 times 3 is 9, this one is multiplied to 1. The check number, here is your check number. 9 times 1 is 9, congruent to 0 modulo 10. We are verifying if that's true. Again, let's do this by batch. This one is 27. Ano ba to? 2. This one is 25. This one is 30 plus 18. 48. 27 plus 25 plus 48. Oh, okay, 100. Yay. That is modulo 10. So that's congruent to the other side of the equation. Okay, so that means 9 satisfy is the correct check number, and this is a valid code for the product. 100 divided 10 is 10, remainder 0. Okay, now finally, how about credit card numbers? So obviously, credit card numbers also very very useful nowadays, especially in digital payments. Diba? Over the internet, we can input our credit card numbers to pay for what we order online. So there are times that maybe we will input the wrong incorrectly, our credit card incorrectly, and our phones or our computers will tell us that we did so using the modular arithmetic, or using through the calculations that they did with the check number. So in credit card numbers, anong algorithm yung gagamitin? So the Lon's algorithm. And we are still working, or we're still using mod 10 arithmetic. So easier. Ano po? So usually we will be dealing with 13 to 16 digits. And each credit card numbers, actually, yung first numbers ng credit card tells you about the issuer. If you are using a MasterCard, the prefix or the first two numbers will be from 51 to 55. And it's usually 16 digit long. If Visa, 4 ang first digit and 13 to 16 long ang credit card number. And if American Express, this prefixes, 34 to 37. It is usually 15-digit long. So how do we do the Luntz algorithm? So it's a little bit different from what we did a while ago. So if in ISBN we multiply the digits, each digit using different numbers, from 10, 9, 8, and so on, respectively. And if in UPC, Universal Product Code, our multipliers are 3 and 1 alternatingly, dito kakaiba yung ginagawa natin. So here we just copy the digits, the credit card number, and starting from here, the rightmost, we look at the second to the last, next to last, or second to last digit. The last digit is 8, so next to last is 9 in this case. And um, from right, this is the right and this is the left, double the digit, um, double every other digit rather. So 9, second to the last. So 2 you don't double. This is the next. You double 1 also. 0 you don't. This one you also double. 4 you don't double. 3 you double. The 1, the 8, the 3, and the 5 you also double that. So the double of 9 is 18. The double of 1 is 2. The double of 1 is 2. The double of 3 is 6. Multiply mo lang sa 2. 3 times 2, 6. Not 3 times 3, ha? That's that's squared. You're just doubling. 1 times 2 is 2. 8 times 2, 16. 3 times 2 is 6. 5 times 2 is 10. And then afterwards, you add the digits. Warning lang na pag naging double digit yung answer mo, hindi 10 yung iyong i-add sa 2. What you will add is 10, that's not 10 plus 2, 10 plus 0 plus 2. You will break down the double digits into individual digits. So that's why you have a parenthesis here for 10, which has a digit of 1 and 0. So you will add 1 plus 0. And in 18 here, 1 plus 8. You get a 60, the total sum. Now 60 is this congruence equation true? Yes. 60 divided 10 is 6. Remainder 0. So this is a valid credit card number. Okay, finally, let's try solving this on our own. So let's copy first 0, 1, 6, 0, 1, 1, 0, 1, 2, 3, 9, 1, 4, 5, 2, 3. Wow, this is very long. Let's encircle the digits that we will double. Copy 7, 2, the double of 1, 3, the double of 2 is 4, 5, the double of 4 is 8, copy 1, the double of 9 is 18, the double of 2 is 4, the double of 0 is still 0, the double of 1 is 2, the double is, 0, just copy, 6, the double of 6 is 12. And then, what are the double digits that we have here? We have a 12, and we have an 18, so that means 1 plus 2, plus 0, plus 2, plus 1, plus 0, plus 1, plus 4, plus 3, plus 1, plus 8. Break down mo yung 18, plus 1, plus 8, plus 5, plus 4. This is very long. Plus 3, plus 2, plus 7. That's why you need computers for this. Ano po? But we are doing this manually. Check if it satisfies this congruence. And again, let's solve per batch para hindi tayo malito. This is 3. This is also 3. So this is 6. I forgot to put the plus sign here. This is an 8. 1 plus 8, 1 plus 1 plus 8, 9 plus 9, 18. This here is also a 9. This is 7, 8, 9, 10, 11, 12. 12. So if we add them together, 6 plus 8 plus 18 plus 9 plus 12, this is a 53. And we can already see that it doesn't, the congruence is not true. So this is not a valid, credit card number. Okay, so I hope you understand these applications.